Day 564 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2659, make array empty. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums containing distinct numbers. You can perform the following operations until the array is empty. If the first element has the smallest value, remove it. Otherwise, put the first element at the end of the array. Return an integer denoting the number of operations it takes to make nums empty. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input nums equals an array of integers 3, 4, and -1. The output is 5. The output is 5 because it took 5 operations to make this array empty when we follow these rules right here. So let's go through these operations so we can see how we did it. So the first operation, it says, first it says if the first element has the smallest value, remove it. Then it says otherwise, meaning if the first element does not have the smallest value, put the first element at the end of the array. Boom. So in this case, 3 does not have the smallest value. In this array right here, this input array, 3 does not have the smallest value. -1 has the smallest value. Since 3 doesn't have the smallest value, then we need to put the first element at the end of the array. So we're going to move this 3 to the end of the array, and that's going to be operation 1. After operation 1, it will look like this. 3 will be at the end of the array, and then it will be 4 and -1. We still need to do another operation because 4 is not the smallest number in the array, right? It's still -1. So once again, we have to move this 4 to the back, and now we have 4 right here in the back, -1 in the front. Boom. So now we have -1 in the front. It is the first element, and it does have the smallest value, so we can remove it. Boom. So we remove -1, and we're left with this, and that's on the third operation. Once again, now we have 3 and 4. 3 has the smallest value, so we can remove it. Now we're left with just 4. And once we remove this 4, that was 5 operations in total. So that's how the output is 5. Now, just in case that didn't make sense, let's take a look at example 2. So let's see. In example 2, our input nums equals an array of integers 1, 2, 4, and 3. The output is 5 again. So in this array, 1 is the smallest element, right? So we can remove it. So after we remove it, that's the first operation, and we're left with this array. When we have this array, 2 is the first element and it's also the smallest, so we can remove it. So after we remove it, we're left with 4 and 3 after the second operation. Now, when we are left with 4 and 3, 4 comes first and it is not the smallest. So you know what that means. We have to move it to the back because it's not the smallest. So now after we move it to the back, that counts as an operation. That's 3 operations total, and now the array looks like 3 and 4. Now that 3 is the first element and it's the smallest, we can remove it. Then we can remove the 4 when it's right there by itself, and in total that took 5 operations, and that's why our output is 5. And just in case that didn't make sense, y'all, don't worry, we're gonna get to example 3 as well. So in example 3, we have the input nums equals an array of integers 1, 2, and 3. The output is 3. This time we could just go down the line, y'all. We have, because it's already sorted. So we have 1 is first, and it's the smallest element. We can remove it. That's 1 operation. Boom. Now we're left with 2, 3. 2 is first and the smallest element, so we can remove it. Now we're left with just 3, and that took 2 operations. Then finally, on the third operation, we can remove the 3, and that's how was our third operation. And now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult now. The first thing we're going to do is we are going to check if the array is empty, then no operations are needed, and we could just return 0. So we're going to say guard exclamation point nums dot is empty, meaning it's not empty, else we can open up the brackets and we can return 0, just like that, y'all. Boom. Then we're going to initialize the result with the total number of elements. So for that, we'll just declare a variable called result, and we'll set that equal to nums.count. Boom. Then we need an index variable for iterating through nums. So we're going to come right here, declare a variable called I, set that equal to 0 to start. Boom. Now we're going to create a dictionary that will store the index position of each element in nums. The key will be the number, and the value will be its index in the original array. So we're going to declare a variable called dict. We're going to say colon, open up the square brackets. We're going to say int colon int. Come outside of that, and we're going to initialize it with a blank dictionary like that. Boom. Now we're going to populate the dictionary with each number's original index. So we're going to come underneath this. We're going to start a while loop and say while I is less than k. We're going to open up the brackets and we're going to say dict square bracket nums square bracket I. And we're going to come outside both of those square brackets and set that equal to I. Come underneath that and we're going to increment I by saying plus equals 1. Now we need to sort the numbers in ascending order, and this will help determine the order in which elements are removed more optimally. So we'll come underneath this while loop right here, and we will say, declare a variable called sorted list, set that equal to nums.sorted. We're going to open up the brackets, and we're going to say $0 is less than $1. Boom. Now we're going to start from the second element in the sorted list. So we're going to say, come underneath this, declare a variable called j, set that equal to 1. And we're going to say, we're going to loop through the sorted numbers and check how they appear in their original order by saying, while j is less than k. We're going to open up the brackets and we're going to set next equal to the current number in the sorted order. So we're going to say, let next equal sorted list square bracket j. Come underneath that and we're going to set prev equal to the previous number in sorted order. So we're going to say let prev equal sorted list square bracket j minus 1. Boom. Then if the index of the next in the original array is smaller than prev, it means the array has wrapped around or the sequence was broken, so a full rotation of the remaining elements is needed. So we'll come underneath this and we'll say if dict square bracket next exclamation point is less than dict square bracket prev exclamation point. We're going to open up the brackets. We're going to say result plus equals k minus j. Then we're going to move the next pair by coming right here underneath this. We're going to say j plus equals 1. And finally, we're going to return the total number of operations required to empty the array by coming right here. And we could just say return results, y'all. Boom, that's all she wrote. Let's give it a run. Make sure it runs properly before we submit it. Okay, we have an error. So can I find K in scope? So we need to declare K by coming right here. And we could just declare a variable called K. And we'll set that equal to nums.count. And that's just going to store the length of the array. So now that we have K, let's run it. Let's run it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 64 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.